Okay, continuing with Introduction to Equations, let's proceed by looking at something like this. 2x equals 4, where x is equal to 2. And again, we want to go ahead and plug that number right on in and see if it makes the equation valid. So plugging in 2 times x, which is equal to 2, equals, with a question mark, 4. And of course 2 times 2 is indeed, certainly not 2, 2 times 2 is indeed 4, which is equal to 4. So when I plug this guy in, the equation is equal. So therefore, yes, x equal 2 is a solution of that equation. Let's do something slightly more complex. Let's say we have 3x minus 1 equals 7, where x is equal to 2. Let's see if that's a solution to this equation. So we'll just plug it in. 3 parentheses 2, which is the same thing as 3 dot 2, 3 times 2, minus 1 equals, with a question mark, 7. 3 times 2 is 6, minus 1 equals, with a question mark, 7. And because obviously 6 minus 1 is 5, this is not equal to 7, and so x equal 2 is not a solution of the equation. So you'll see that as a kind of a common theme as we go through here, that you can actually, when you solve an equation in algebra, we'll do this a couple times, in a minute when we actually learn how to solve the equations. Once you find the solution, I'm going to teach you all kinds of methods to quickly and easily find the solutions of these equations. And once you find the solution, you can actually plug in the answer and see if you're correct. So that's the great thing about algebra. You almost always know if you're correct. So let's take the problem y over 7 is equal to 28, where, make a correction, y over 7 is equal to 4, where y is equal to 28. Let's just plug it in. Y is 28, so 28 over 7 equals, with a question mark, 4. I'm going to continue this way. The double arrow just means I'm continuing the problem. 28 divided by 7 is indeed 4, which is equal to 4. So yes, 28 is a solution to that equation. Let's do one like this. X over 5 equals x, where x equals 0. Now, this is a little different. I've got x in 2 spots, but that's okay. It's just an equation, so I just got to plug it in. Let's say x is 0, so I'm going to continue over here. So 0 over here, 0 over 5 equals, with a question mark, x, where x is 0. Now, 0 divided by anything is big fat 0, which is always equal to 0. So yes, this is a solution to that equation. 0 is a solution to that equation. Okay, let's go ahead and do one more problem of this type. Call it plug and chug, and then we'll actually move on and learn how to solve some of this thing. Solve some of these things from scratch. Let's take a problem a little bit more complicated. 3k plus 5 equals 5k minus 1. K is equal to 3. Now notice in all these problems I'm using different letters. And that's just trying to teach you that the letter doesn't matter. I could have W there, X, Y, Z, A, B, whatever. It doesn't matter. The letters are just a placeholder. So it doesn't really matter what the letter is. So let's go ahead and see if K equals 3 is a solution to this equation. So we'll plug it in. 3 times K, which is 3, plus 5 equals, with a question mark, 5k, which is again 3, minus 1. 3 times 3 is 9. We'll just carry through with the plus 5, equals, with a question mark. 5 times 3 is 15, minus 1. 9 plus 5 is 14, equals 15 minus 1 is 14. So since the equation is validated and the left side is equal to the right side, we can say yes, indeed, k equals 3 is a solution to this equation right here. Just like that. So if you ever asked in your problems to, verify yes or no if a certain thing is a solution to the equation, you just plug it in. And so you see, algebra is very much building blocks. You have to know how to multiply positive and negative numbers. You have to know how to add and subtract positive and negative numbers in order to do any of the other things. And that's why we started out with that. Okay, now let's, at this point, start to solve some equations. I'm going to teach you some basic strategies for learning how to solve them. Let's just dive right on in, and let's take a simple equation. X minus 7 is equal to 3. Now let's just talk about this for a minute. That's an equation. We know it's an equation because it has an equal sign. And what it's saying is, of all the numbers in the universe, negative infinity all the way to positive infinity, and all numbers in between, only one will satisfy this equation. So that when I put that one number in this placeholder of x and I subtract 7 from it, you will equal 3. Okay? Now, this is a pretty simple equation. And I think that you could convince yourself by staring at it that the only number that can go in here is going to be 10. 10 minus 7 is 3. And that's what the right-hand side is equal. So even without even doing anything, the answer is going to be 10. I guarantee you that. Okay? But the trick is, or the problem is, this is the simplest equation possible. And you cannot skip steps like what we just did in solving your equations. I'm going to teach you some methods to systematically solve the equation for the variable x so that you will have a systematic way of finding out what x is equal to. In this case, we know it's going to be equal to 10. And basically, what we need to do is we need to do whatever it takes to this equation to isolate this variable. That's the one we're solving for, x. We need to do whatever we need to do to isolate it. In this case, we have a subtraction going on here. And what we need to do is get rid of this negative 7. We need to move this negative 7 kind of over here somewhere and just kind of get it away from by itself. And then once it's gone, x will be by itself on one side of the equal sign. And once we have x on one side of the equal sign by itself, whatever's on the other side is what x is equal to. So no matter how complicated the equation, I want you to remember one thing and one thing only. When you're solving equations for the variable x or whatever it is, your goal is to do all the mathematical tricks that are legal to isolate this variable on one side of the equal sign, and then you've solved it. Okay? The other rule to remember is that, well, what's legal? Can I just do whatever I want? Well, no. It's kind of like fractions. Remember, in fractions, I told you, if you had 49 over, 7, okay? Well, I could do anything I wanted to this fraction as long as I did it to the top and to the bottom. Okay, I can multiply this fraction by 2 over 2. I can multiply this fraction by 21 over 21. As long as I do it to the top and the bottom, you're good to go. You're not going to alter the fraction because you're doing it to both sides. The same is true of an equation. You can do pretty much anything you want to the equation as long as you do it to both sides of the equal sign. Then the equation is not altered. It looks different, but you haven't really altered it. So let's just take an example. We want to get x by itself, but we've got this nasty old minus 7 here. So how do we get x by itself? All we need to do is add 7. So let's see what happens. If we add 7 to both sides of the equal sign, because remember, whatever you decide to do to one side, you have to do it to the other side. So let's say x minus 7. I haven't done anything yet. I've just written this down. Now let's go ahead and add 7. Plus 7 equals 3. Now I've added 7 to this side. I must add 7 to this side. Otherwise, it's not legal. So I haven't really altered anything. All I've done is add 7 to both sides of the equal sign. And this little trick is, we learned from before, negative 7 plus 7 is going to be 0. So I've used this trick to eliminate this from the equation. Now there's nothing left on this side of the equal sign except x. And so x is equal to 3 plus 7, which is equal to 10. And that's what we knew we were going to end up with at the very beginning of this thing. So what we did was we basically added the opposite here. And if this were an addition, plus 7, we would have to subtract a 7. So basically, you just do the opposite. And the opposite of subtraction is addition, and the opposite of addition is subtraction. And later on, in some more problems we're going to see here in just a minute, the opposite of multiplication is, you guessed it, division. And the opposite of division is multiplication. All you need to do is know your opposites, and then you've got no issues. So let's take y plus 7 is equal to 12. And of course we want to solve this equation for y. We want to isolate y by itself, so we want to get rid of the 7, and we're adding 7, so in order to get rid of it we need to subtract 7. So I say y plus 7, that's just this, minus 7 is equal to 12, and I must do the operation to both sides, so I put a minus 7. I've subtracted 7 from both sides. This goes away because 7 minus 7 is 0. So I'm then left with y is equal to 12 minus 7, which is simply equal to 5. So y is equal to 5. And that's the answer. Now let's say I have something like negative 37 plus z is equal to 37. Again, I want to get z by itself. That's how I'm solving for z. But I've got this negative 37 hanging out here. In order to get rid of it, I need to add 37 because I've got a negative going on here. I need to add 37 to both sides in order to cancel out this negative 37. So I've got negative 37, and I'm going to add 37 to it, plus z. All I've done is insert a plus 37 here, equals 37 from this side. And again, I need to add 37 because I got to do it to both sides. That's the rule number 2. This goes away, and it goes to 0. This little arrow means it goes to 0. So then z is going to equal to 37 plus 37, which is simply equal to 74. And that is the answer. So you see, it's pretty methodical. It's pretty methodical. And you see, it's very repetitive too. All you need to do is work a lot of problems, you know, and as we go forward, I don't want to give you the impression that all the equations are going to be this easy. I mean, these are fairly easy equations, but the basic principle is exactly the same, no matter how complicated your equation is. If you're trying to solve for the variable, you know, if you have an equation in a single variable like this, where it's got one letter in there, all you do is you just apply your tricks, which basically your tricks are knowing what's the opposite, to go ahead and subtract and add and so forth. Now let's take something a little bit more complicated looking. Let's say we've got 4/3 equals minus 2/3 plus x. Now I'm going to work this way to save some space. I want to get x by itself, but I'm subtracting 2/3 here. You know, minus 2/3 plus x is the same thing as x minus 2/3. So in order to get it by itself, I need to add 2/3 to the side, and that'll cancel it out. So working just like this, 4/3 plus 2/3 is equal to 2/3 minus 2/3 plus x. And this looks a little bit different than the problem before, but it's exactly the same. All I've done is on this side of the equation, on the right hand side, I've added a 2/3 in, and then on this side of the equation I've added a 2/3 in. And when I have fraction with the same denominator, this is just going to be equal to 6/3 on the left, which is equal to, and this goes away and goes to 0, so this is going to be equal to x. And then of course 6 divided by 3 is 2, so x is simply equal to 2. That is the answer.